But wait till Young's here. Young's here?
Oh, okay, Young isn't here.
Yeah, well.
Yeah, I'm
Oh,
here.
oh, he's
You're
here.
there?
There we
Okay.
go.
Yeah,
Okay.
I,
Welcome back
Who
to
else is
another
here?
session.
Who else is here? Is that Anthony?
That's Sir Bailey, I think, because that says
Oh, really?
Sir. Yeah,
Hi,
Sir
Sir
Bailey.
Bailey.
Yeah.
Hi, sir.
Well, probably he's away or something. I don't know.
Okay, yeah. Could be he's not back yet. Just
Yeah.
has
Mm-hmm.
it open.
Yeah.
Um, yeah. Okay. Well, I'm ready to go.
Mm-hmm.
We ready to continue?
Good.
yeah.
Okay, we're gonna do details.
Mm-hmm.
Details now.
Yeah.
So, Young, what I'd like to do is copy the structure we see, everything we see, make a whole copy of, and if you take the whole column, it doesn't matter. We'll clip it later. But yeah, capture everything and the columns. Yeah, that's right. And let's make a copy of it and put it beside. Don't do anything else yet. Just make a copy. Or
Yeah, okay, let
okay,
me.
if you want to trim it, if you can trim it there, that's fine. But only to make a copy, right? We're not going to actually trim anything. Like I want to keep the original model too, right?
Okay,
I don't want
so
to.
let's.
I don't want to undo anything. So if you capture the columns, we can trim them later. And make it. Yeah, that's it. Put them over by the side. Now you can trim where they pass, down past our past that plane. So the plane would not, have a hole in it or anything. Yeah, that's it. And we'll just crop the column length so that's all above. So that would now be the floor, right? This is like a table sitting on the floor.
Mm-hmm. So this is the floor?
Yep, that'll become a floor that we're standing on it while we do this work, right? We have a little tent, sort of a rig, of a little experiment, right? An experimental bench. It's like a bench.
Yeah, let
Um,
me erase this first.
okay, yeah, we can just extend legs, yeah.
Yeah.
Okay. We could actually give a material now to those legs. Let's make those legs angles
Angle?
two by two, 2 by 2 by 1/8 angle.
So like this?
Yep,
Okay.
1/8 thick,
2 inch
2 inch.
by 2 inch,
Yep.
1 inch less. Mhm. Mm. Yes, yeah.
So that looks like a two by fours, right? Oh no.
Okay.
Yeah.
The thickness is 1/8. So it's an angle. Yeah.
Oh, 1/8.
Yeah. 1/8 inch thick. Yeah. That's 1/8. Yeah. Yeah. And the other one. Yeah. Both legs. Yeah. 1/8. Yeah. That's it. Good. Oh, 2 by 2 by 1/8, and we can extrude that to make the material up to the top of the the pyramid, the base of the pyramid above. Yep. Okay. Yep, that's it. And then we can put them around for the four legs, same way. Okay. And then at the top, I'd use the same angle, and I make a corner like for the tabletop, you see, so like a corner, maybe corner cut, you know, like a miter cut, like a picture frame.
Yeah.
And we can hang the 2x2 over the leg, so you know what I mean. The flange will go on top of that, you know, it'll sit on the, you know, it's like, yeah, we use it like an edging, you know, like, I don't know if you can see my like it sits on top like that.
Oh, okay. So it's a square or something?
Yeah, it's the same material.
Yeah,
Same.
same
You can
material.
use exactly the same material. So, in fact, you could take that same material and just rotate it horizontal.
Okay. So same material and same shape?
Material,
Same shape?
rotate it, yeah, rotate it horizontal, and then we'll fit it like over, so it'll hang on top of the leg, right? It'll go like over the leg.
This way?
I can't quite see. No, swing, like one of those are gonna land on top, like, you know, put it over the top of the leg.
Yeah.
Horizontal sits on top of the, you know, like a corner, like the edge of a table.
At the edge of the table.
Yeah, it makes like the edge of the table.
Oh, so it's
You sort of hang it on the top, right?
like
Yeah.
this?
Turn it horizontal. Rotate.
Oh, rotate.
Yeah, rotate horizontal.
Which is the
Copy.
point?
Yeah, just like turn it.
Turn it from this period?
Yeah, pivot there, horizontal.
And what's the angle?
To me, the cross section still looks vertical. When I rotate it, yeah, that's it. Rotated so that, you know, so that the cross section will become horizontal cross section, and you'll have to move it out a little bit and rotate it like in the other dimension, okay, in the Z dimension, you're rotating, I guess, you know, comparatively, you know what I mean? It's like, yeah, push a leg.
So
it's like, if I could take that piece, I would just like turn it horizontally. Right now it's vertical, right? Just take that piece, tip it horizontal.
So basically, you are trying to build a beam, right?
Well, yeah, it's an edge.
A beam from the tip of the pyramid to the base of the pyramid, right?
No, it's just the edge of the top of the. Yeah, it's the base of the pyramid, right?
Yeah.
We're creating the base of the pyramid.
Basically, you make the connection from the tip to.
So just take that piece, right? And right now it's vertical, right? Lay it down horizontal on the floor. Just lay it down on the floor, horizontal. So rotate it from the bottom, let's say.
Lay it down?
Yeah.
Here?
You tip it over on the floor. Yeah. Just as it is. Just copy a copy of it. What? Don't make it bigger. Oh, okay.
It's the same size.
Oh, okay. You're zooming
put it
in.
somewhere.
Yeah, you're zooming in. Okay.
Okay. And then what?
Well, rotate it this way. I mean, on the horizontal plane, the leg to the left. Can you move the whole piece?
Okay. So
can you take the whole piece over on its, you know,
Yeah.
rotate to the floor? Yeah, like Well, I don't know if you haven't really rotated.
He
Yeah.
he did well.
So you want me rotate it. Let me find the surface first.
Yeah, so it's like lay it on the floor. You see the floor or the plane. We're going to put it on its edge on the floor, just rotating it,
Here?
Well, no,
No, no,
that's
no.
not the plane.
它是
Try the
用
other plane.
两个边儿不动，两
No,
个角不
no.
动。
So
Move the
this
facing, this
Yeah.
leg, move it downward, rotate it.
this surface.
Yeah, that's up, right? That surface up.
Man. No, I'm not talking about a surface.
Yeah, but
Yeah,
the same
yeah.
thing.
But
Ideas.
if I want to rotate, I need to find the surface. So this
Yeah.
way?
No.
Yeah, but you're missing the rotation that I want. I don't know. This is frustrating, but
So basically, you want to create the same thing, just lay on flat on the ground, right?
yeah, that's what I'm saying.
Yeah, yeah. I mean, he's
Think
doing
about that piece
yeah.
as a piece and just rotate it. So look at where the edge of the table is. That's where I want to rotate it to. Not the bottom. Well, it could be at the bottom as well. But
Okay.
we're framing the edge. Framing the edge of the table with the same angle. I'm going to use to frame the edge of the table, like a picture frame, all the way around. So
Yeah, he's talking about the horizontal side. Okay.
the horizontal lines. Yeah, the top table.
We
The
thought you were
edge.
talking about the slanted edge.
So tip it.
So it may be rotated this way?
No. No. Well, yes, that's a beginning.
Yeah.
Now rotate it around. Now rotate it around in another the z-axis now, and try the z-axis rotation now. There.
Yeah.
Now. Okay. Now move it in. Move it in to over, so it'll be over the leg. Yeah. And
Yeah.
extrude it in the depth now. Extrude it that way.
Here?
Yeah, that way.
Yeah.
Okay, good. So that's what it is all the way around. Like a picture frame. It's like a picture frame. We have a miter cut.
Okay.
Yeah, he's talking about the horizontal.
I was gonna blow some air and almost.
Yeah, that's the horizontal edges of the table.
Okay. So
Horizontal edges. Yeah, sorry, sometimes it's just hard to.
Yeah, I thought you want to do the slope.
It's the edging of the top.
Yeah,
of the
edging of the
pyramid.
Yeah.
And here we bring them and overlap them completely, and then take out the interference. Yeah, it'll be a corner cut.
Yeah.
A miter cut.
Miter cut. Yeah, from corner to corner.
Yeah, corner miter cut, like a picture frame.
Yeah.
It's a picture frame kind of cut.
Yeah.
So like this?
Yeah. Yeah, that's it. Yeah.
From the four corner?
Yeah, all like that. Okay, that's a basic. So that's a basic table, right? And you see we've got the overlapping arm of the angles. We can put a little bolts through. We can put a little fastener, maybe self-tapping screw. I don't know, whatever. It's we can put an angle in like a bracket into the corner for stiffness if we need to.
Yeah.
Look from the bottom.
Yeah.
And look up in, see where you could put like a angle bracket, a right angle bracket.
Yeah.
Right in the top, right into the top, so it lays up against the top of the table. You see the edge, so it fits into that corner, a right angle. Flat,
this way?
Flat plate, a flat plate that fits in there. Up against the top, the underside, up against the underside of there. So it's just not a
So this way? Like
a plate?
Well,
no. a plate, not exactly like that. I would say, okay, extend arms outward to each side a little bit. So it's
Here,
a bracket. It's a flat bracket
this
uh,
way.
corner. No, not that way. Pull horizontally, not vertically. Not vertical. Yeah, pull the plate out horizontally, on both sides. Yeah, pull that edge. Yeah,
Oh,
that edge. Right. That's it. And then make another arm. So this is an angle flat plate. It's just to reinforce the corner.
reinforce the corner.
Yeah. A right.
So just like this.
You know, you had a good start. Pull out one corner, one edge, and then pull out the other edge as well. So yeah, pull that out
One
more
inch.
like an inch or two, a little longer, right? A little bit more. Yeah, that's like that. And now make a similar pull out the other direction. Yeah, and see that's a plate, right? And it's a bracket. Yeah, but now make it a bracket means it's just fitting. Yeah, so you take that square out. See the square we can see? We could just remove that. Yeah, and see what we've got is a reinforcing plate. You can buy those things, right? This is a corner bracket.
Yeah.
From the hardware store. Okay, so now you see how it's fastened, right? It's very strong. It's got a leg. We can fasten into the leg, and so we've got a structure. Yeah, we've got the structure, and now we just need to do the pyramid. So remember when we did the PyraPOD 8, what we used is an I-beam.
Yeah.
Okay, this time we won't use an I-beam. I'll use a T section.
The same material?
So, the section of the I looks like a capital I, but the section we will use this time will look like a capital T.
Capital T.
Capital T.
Capital T. That's the look of the cross section of those edges of the pyramid. So
okay.
yeah, so we can create like a T if we look right on the cross section of the line.
So what's the size of the T?
Okay, 2 inches across at the top. The top of the T.
2 inch. And
Hello.
Hi.
Hi.
Can I come out?
Okay, I'll come out. Hold on a sec. Maybe you guys can do this. I'm just gonna
Okay.
I'm just gonna
So
go
basically
for a minute,
T,
okay?
right?
oh,
So
Gotta go
basically
to the
T.
door.
T, yeah. He's,
T, capital T.
T is T may be stronger. I thought he's gonna use L.
so
You know T, right?
yeah, like this, and this way maybe 2 inch, and 1/4.
Something like that, maybe. In the center, yeah. Is it in the center? Looks like it's, oh yeah, it's center, yeah. T.
T like this.
It should be stand up T. It
Yeah,
should be very- yeah,
I'll
yeah,
move it.
yeah, move it, yeah.
Stand up.
Why T?
Stand up.
Yeah, stand up. Oh, I see. The reason for that is just so that the bubble generator can fit. Well, if it's a L, why not using L?
So pull the T.
Yeah, pull the T, but then the T should drop, right? Should be lower, right?
Mm-hmm.
So the
Let me rotate it.
but that should be even lower, right?
Yeah.
Yeah, okay. Gonna drop, yeah, pull in.
Oh. Let's see if it's the same straight line.
Yeah.
And lower.
Yeah, that's it. You got it. So it's very much like the I-beam, but it's a little bit simpler, right?
Yeah,
A little bit simpler. T is a little bit simpler.
yeah.
And we can buy a T, but you can't buy an I, not at that size, right? We're going to use small size.
So why don't you use the corner?
No, because this will be easier to put everything over and to
Okay,
make
I
certain
see.
connection and
Okay.
so on.
Yeah, flat. You got some flat surface to work with. Okay.
Yeah,
I
flat
see.
surface, and also it's like centered, right?
Right, centered. Yeah.
Nice and metric.
Mm-hmm.
And it's a little bit like the PyraPOD H, you know, but
Yeah.
it's a T instead of an I.
Yeah.
So in some ways we'll have some similarity.
Yeah.
And you know, we never really designed fully how the bubble machine would go in the PyraPOD 8. So we're going to probably learn about that when we build this one.
Yeah.
There will be kind of similarities.
Mm-hmm.
So how the T connects with the frame? Like the
So,
table?
what we could do, I would say, yeah, we'll have to look, you know, for a
Corner cut.
reasonably simple way, yeah, to fit it and make it. See that corner. Maybe what we do is we sink it down a little bit more so it comes right on the edge. Like, you know what I mean? Push it more into the
Lower.
into the frame below.
Into
you
the
know,
frame?
push it a little bit more into, yeah, like that. And see how it looks from the other side. See, it's going to go across that corner. I'll tell you what, we need to cut that corner off, actually, because, you know, that kind of corner, well, I'm not sure, you know, because initially, depends on how we cover this, but,
Yeah.
so, okay,
So maybe move it to the corner?
about like that, yeah, that looks about right, yeah. Does that mean we want to, you know, but then we have to be, you know, I mean, we still have to make our connections for the tabletop, so I'm not sure if we can just cut that away. I think the whole corner comes apart.
Yeah. Yeah.
But let's say we can just fasten the T section to the corner like that, and we'll figure that out later. Okay, we'll figure out how we're going to fasten it.
Yeah.
Okay.
Yeah, there's gonna be a way that we can tie that, and at the top we can use the solution we had before, right?
Yeah.
Remember the brackets that you already designed?
Yeah. I-beam.
Yeah.
Mm.
You did a nice bracket at the top.
Yeah, so maybe it
Right.
cannot fix like the corner. So when I do, I'll put the top of the
Yeah,
Yeah.
that's like
area.
we did before. It's the same
Yeah,
kind
Yeah.
of
and
cut
we
that you made
turn
with the
this
I-beam. Yeah.
to
Yeah.
90 degree and
Yeah.
times 3.
90-degree would be, yeah.
Yeah,
Okay.
and cut from here
Yeah.
Uh-huh.
to here. Oh, okay, from the top. Just, okay,
Mm.
Right.
and from the bottom, you can just cut here. Okay,
Yeah. If that miter cut is too complicated, you could even have a little square gap where they don't necessarily have to meet. There could be a little gap, right there if you cut straight through.
yeah, I think
And
it's okay.
yeah. So
We just delete this part.
yeah.
And let's see.
Okay, yeah. So the top could close, but we could have like a little square gap where they just kind of meet. Yeah. So they're meeting, but they don't really, they're not like miter cut there. So filling like because it's very small, right? It's only a T. It's probably 1/8, right? It's a 1/8 inch. So
Yeah,
it's
yeah,
a tiny square, a tiny square gap that we have where the legs of the T, right? They meet, but we can't like make them fit precise like this, right? Like we can on
so
the
this is the
yeah
like the section. We just
okay
cut here, one
yeah
cut, and
Yeah.
here,
okay
one cut,
Yeah.
just like an
Good.
arrow.
yeah okay
Yeah.
okay
So it
and
can be
and
connected
then it
together.
fits together. And then we have a bracket at the top. You made a bracket there before for the
Yeah, yeah, yeah. Okay.
I-beam. So it's the same kind of thing as we did with the I-beam.
Yeah.
So we have
Okay.
4 brackets that go in, and we can bolt them at the top there.
Yeah.
Okay. You can do it later.
Yeah.
Yeah.
Do it later.
Okay.
Okay. So now you see with that leg, right, of the T, when we look at the bubble machine,
Yeah.
and we see the sides of the bubble machine at the top, you can see how they can fasten to the leg of the T. And we fit the bubble machine inside, just inside. See, now we have an interference, right? But
Yeah.
we shrink the bubble machine just a little bit so that the
I
sheet
see.
metal is against the edge of the leg of the T.
Yeah.
Right? And we can fasten to the leg of the T along the top. And we still have an open top, but we can reach inside the bubble machine.
Yeah. So
And now,
let me redo that.
yeah, make the bubble machine, see where it interferes. We'll make it smaller, so pull it inward, so it's come against the outside of the T, edge of the T.
So
Designers.
Yeah.
But these things, okay? Like how they.
So right
the
now it's like
design,
in the
how
leg
they-
of the T, yeah,
because
there.
the
So we
engineers,
can
yeah,
push that
it's
back,
amazing.
push that back like that. Okay,
Yeah.
perfect. We do that around the whole way.
Yeah. Virtual. This is virtual building.
Yeah, we see everything, right? We see all the.
We're going to take our
It's
dough.
so fantastic. Now, let's give the bubble box a little bit of thickness, say like 1/16.
1/16.
Yeah. Let's say it's a sheet metal. Maybe it's steel.
1/16 or
well,
1/8.
1/16. Yeah, no, it's light, right? It's got to
Yeah.
be like sheet metal.
Yeah. 1/16. Yeah.
So might even be lighter than 1/16, but
Hmm.
So just to indicate that it's much thinner than the T. The T is 1/8, right, which we can buy from hardware.
oh, the T is 1/8.
Yeah, the T is 1/8 thick.
I make quarter inch.
Oh, okay. Well, quarter is pretty heavy, but you can find, you can get that kind of T at quarter as like a fence post, right, Anthony? You know those T's are used a lot for fences or for like a stop sign. You'll see some stop signs.
Sign. Yeah.
Yeah,
Mm-hmm.
and they're using this kind of. So it could be 1/4, it could be 1/8.
Yeah. Don't change it now. Maybe.
Don't change it
Oh.
now.
Yeah.
Now 1/4.
Okay. Okay.
And the sheet metal, we make it 1/16,
1/16.
and we bring it like right on the edge, so it's slipped in between the T, right?
Yeah.
The legs of the T, just slides right up beside it, and then we can fasten it
Yeah. We can fasten it onto the T, right?
to the T. Yeah, we
Right.
fasten it to the leg of the T,
Yeah. So we got two sides fastened.
and the other side is hanging. That's why I meant, what if we can do it from one sheet, right? We do all
Right.
three,
One sheet is best.
one sheet.
Yeah.
And we can fasten the bubble box,
Yeah.
to the T.
Yeah.
So it just hangs in there.
Yeah.
You could use pop rivets or sheet metal screw.
Yeah.
And we just take the body, the bubble machine, and
Yeah.
we fasten it along the top there.
Mm-hmm.
Okay. I just delete the rest.
Yeah, that's it. Okay.
Don't need that one.
So in one of the pyramid face, one of the quadrant, we have one bubble machine. In the proper model, we'd have one on opposite, right? We'd have two bubble machines. We'd have the one opposite, but we won't bother with that right now.
Yeah. Okay.
Oh, it's just a mock-up,
Yeah. Mock up.
and one machine is sufficient.
Yeah. because we're gonna fill the entire space.
Yeah, we're
No
not going to make
cavity.
a bubble
Yeah.
cavity.
Yeah.
So there's no, you know, bubble bag. You know, we're not blowing into a bubble bag.
Right.
We're
This
just
is
blowing into the
this is
space.
easier for testing. You know, right?
Yeah, this is for testing.
Yeah, for
So,
testing. This is nice.
but we have a complete bubble screen.
Yeah.
So we still need the bubble screen and the
Right.
details for putting the bubble screen in.
Yeah.
So the sheet metal maybe 1/8
Yeah.
or
1/16.
or
1/16.
1/16.
Yeah. Quite thin.
Yeah, quite thin.
Yeah.
1/16. So let's see how to make.
Yeah, that's great. And the bottom is kind of an open, and we'll have some kind of, you know, part that we can fit on the bottom. And that's really like a funnel to drain the liquids out of the bubble box, right? Because
Yeah.
we'll have surplus liquid that
Right.
is not, it's not going to go into the bubble making. It's going to be like a surplus. It's going to be draining.
Mm.
From there, it just goes back to the reservoir.
Okay, so you have the thickness. Yeah.
That's pretty good. So now, you know, to do the bubble screens, we do them the same way. We put a collar into the hole.
Yeah.
Remember
Yeah.
how we did that? That circular collar, like a cylinder, that just goes into the hole, and it extends a little bit out and a little bit in, right? So it's just like a cylinder, same diameter as the hole.
Yeah. Yeah.
And thin wall, and it's a cylinder. It's only like 2 inches long. You know, the length of the cylinder.
So
Yeah,
this
like
way.
that. Yeah, 1 inch out and 1 inch inwardly.
And it's a little bit thicker.
Yeah, it's quite thin. And
Right.
it's also like a sheet metal or polycarbonate, you know, some kind of thin sheet material. And
Yeah.
that cylinder, yeah, it fits inside the hole. Extends inside about 1 inch and outside about 1 inch. So it's about a 2-inch, it's a 2-inch collar, and it's positioned in the middle of the wall.
Okay, so this way, let's go
Half in and half out.
half in.
And that's how we put the screen material. The screen material on the inside, the screen is basically mounted on the inside, and it's like a jar, like the top of a jar. It's like a cap. It's a cap that presses over that collar. And
So is inside or outside?
the actual collar is on the outside of that one,
Oh,
right? Of the screen. The screen itself is carried on another collar. It's just a little bit bigger, and it's slipped over this one. And
Okay.
and it trapped the screen material.
Okay, so
You know, we
Nice.
could also use like a barrel clamp. You know, one of those big strap type of clamp, and the screen material would put it over there, and we just clamp it on that ring. So this collar is like a ring, right? And it could be, it could even be we find a pail or a barrel and use it. You know, something of the right size, and just cut cut a section of the pail
Yeah.
or barrel, right, and use a little bit of the cylinder, right,
Yeah.
and push it into the hole.
Yeah.
Or we just make a collar the
Yeah.
right size
Yeah.
to fit the hole.
Yeah.
So we can make this like. Uh,
So the screen is like putting like a cap on a bottle, right? That's the open bottle. That's
Yeah.
the opening.
Yeah.
And you're just placing the screen over, and
Yeah.
it can
yeah,
it
like
can
we
go
find
over
the
that collar, you know,
Yeah.
and
then
we
just
clamp,
use
we
a
can clamp
bigger
on
one
it.
to clamp it.
Yeah.
Yeah. To
Clamp
hold
it.
it. Yeah.
You could use like a bungee cord, you know, to put the little
Oh yeah.
pressure around.
Bungee cord. Yeah.
So I can use the material here to make
Yeah.
the. Oh, not this one. Here. Like the screen.
Right, that's it.
So the screen can be over the
Yeah.
collar like this.
Yeah, and that screen, right? That's inside the box, right? It's not outside the box. Inside the box.
Or inside box.
Yeah, inside the box. Because the pressure will be pushing it outward, right?
Right.
So, and we can install it inside the box when we go to make a connection to the panels, you know, then we have another connection outside. Right now we don't have that connection, but in the future we will have that connection. So
Okay.
yeah, so the parts of the bubble box go inside the bubble box, including the screen.
Inside the bubble box. So it's not covered color.
Hmm?
Do you mean if this screen is bigger, a little bit bigger than the collar?
It's bigger. It fits over. Yeah, it fits over
Yeah.
the other collar.
Okay.
Yeah.
Like this.
Yeah,
section.
slides over and carries the screen, and it's capturing the screen right in between. So hold the bubble screen, and you can mirror that to the other one.
Mirror that. Oh,
Wow.
they connect together.
Yeah, so maybe we make the circles a little smaller so that we get rid of the interference, or if we can move them away from each other a little bit. You know, maybe the collar doesn't need to be a full inch deep, but yeah, I think an inch is good. Although this is like...
Maybe half inch first. Let me try half
Yeah.
inch.
Yeah, half inch is probably enough. Oh yeah, we have to change the inside collar as well. So the outside collar and the inside collar, make them both, you know, so now the inside collar would only be 1 inch. It would extend a half an inch outside and a half an inch inside. Okay, now they don't interfere.
Yeah.
It looks good. You know, if outside, maybe outside we need a full inch, but we can make it half an inch inside the box.
Yeah, this is 4 inch. This is
Okay, let's leave
half
it.
inch.
Let's leave it
Okay.
at that. So 1 inch extending outside and half an inch inside. And the screens can go over the collar. And so we
Yeah.
have the bubble box, right? We have
Yeah.
a bubble box. We have a way to fasten it. we know we can make it from a sheet metal. We have the screen construction, and we have the opening for the fan.
Mhm.
So now we could search for a fan unit, that can fit into that hole. So the hole is ready to the diameter of the hole now. Considering the table is 4 feet, right? What's
Yeah, let me see
what's
that.
our diameter there?
Diameter is 10-inch.
Well, that's about right. I would
Yeah.
say 10 inches is a reasonable size. So what we would look for is a fan unit, fan unit that includes the fan, the motor, and what they
Mhm.
call the scroll. The scroll is what is like goes around the tips of the blades, right? It's like the guide. It's the guide for the air to come in.
Yeah.
So you can get a fan unit that includes all of those pieces, and it simply fits into the hole. And there needs to be some mounting system to hold it properly, but we have to see what the fan unit looks like first.
Yeah.
Yes.
So we pretty much have the basics, right?
Yeah. So maybe you can just forget about the inlet, right? We can just design the
Yeah.
nozzle, right? And then and the motor.
Yeah, once we've got the rig, so this is like the test rig, right?
Right.
Once we get the rig established, then the details, we can modify them.
Yeah.
We can try out different fans. We can try out different screen material.
Yeah.
This is a kind of for experimental
Right.
use, right?
Yeah.
To learn about the bubbles, and so the main components of it is that we move air.
Yeah.
And we spray water.
Water. Yeah. The nozzle. The nozzle has to be in the right position, right?
Yeah.
Yeah. I mean,
And
a certain distance.
Once we have the test rig, we can design details.
Yeah.
Because we can do it experimentally.
Yeah.
We can get some, like we could even close one of those bubble screen, right? We just put a cap over it.
Yeah.
We could try with one screen at first, just to get a nozzle, get a screen, try it out. Then we replicate it.
Yeah.
And we see also, can we push enough bubbles? Because we want to push bubbles
Right.
into the adjoining panel. So
Yeah.
we need a strong fan.
Yeah.
To push the bubbles.
Yeah.
And we can experiment, to see that we've got the right. We can also do some calculation. How many cubic feet per minute do we think we need?
Right.
What would we aim for?
Yeah.
So that we could get a fan unit that will give us the right CFM.
Right. CFM. Yeah.
It should be a sealed motor that can be wet.
Yeah.
And the fan unit is probably, kind of like you use for radiator. Like one possibility is like when they have air conditioner units or any kind of fan unit for a radiator,
Right.
radiator unit.
Yeah.
Fan units that are used in refrigeration,
That's right. They can.
like truck or recreational vehicle that run on DC fan, small fan for a radiator. Also the automotive radiators.
Yeah.
Well, this is kind of small. Most of the automotive radiators are a little bit bigger.
Yeah.
But that one that we saw for the Mercedes had two fans, but there was only one that was powered directly. The other one was like one fan unit was direct drive, and the other one was powered by a belt.
That's right.
So we might be able to use a fan unit and we just have one of those.
Yeah.
But anyway, I'm not sure that they were 10 inches though. This is pretty small at 10 inches.
Yeah.
You know, compared to automotive radiators.
Yeah. Automotive probably
Mhm.
20.
They're a bit bigger, typical.
20.
Another possibility is we can make this bubble box bigger, right? We designed it now of a certain size, but what if we move the inner, you know, the fan
Yeah.
wall, you know, further away, right?
That's right.
Further
Yeah. Further away,
down,
then that's bigger.
bigger, make a bigger bubble box. We can get a bigger diameter.
Mm-hmm.
You know, the bubble depth of the cavity is 2 feet. So, you know, it could be that almost the top of the pyramid is used for the bubble machine.
That's right. Yeah.
The pyramid, the cap is. I don't expect the bubble machine needs to be that big, like the whole top of the pyramid. No, I don't think so. But we could make it a little bit bigger,
Yeah.
if we want to.
Yeah.
Yeah.
Well, that's the idea of a test rig, right? Now, over the whole thing, we put a kind of a tent, a cover, right?
Yeah.
We could sew it up to fit,
Yeah.
or we could weld it. It could be welded with like PVC, clear material, so we can really see inside, right?
Yeah.
And what we could have still like a clear top cover to the bubble machine. That's really useful. We can reach inside. Another possibility is we get polycarbonate sheet material, and we just lay it down, you know, on top of this, right? We fasten it, we maybe glue it, or, you know, rivet. You know, polycarbonate can be quite thin material, and we could rivet it onto the T section, right? The T's. So we could like make a polycarbonate sheet material, 3 triangles, right? 3 triangle cutouts, and we fasten them on there that do the close up the top part, all clear, so we can really see what's going on. We look inside and see underneath. You know, the bubbles will come right up against the clear material when it fills completely. So we'll see the bubbles really nice. We can take a lot of nice photographs.
Yeah.
And the liquid can just drain back down into the tank below.
Yeah. Yeah.
Now, we haven't
Very
drawn
simple.
the tank.
This is very simple.
We need like a base. We need a base at the bottom of the table. We need a basin.
Yeah. We need a basin. Yeah.
And that could be similar to what we've built, but just you know, like a pan. It's like like the
pan.
table thing and it's standing in the pan.
Yeah.
Maybe we make a sheet metal pan.
Sheet metal,
you know,
pan.
Galvanized steel.
Or use you know, something to support it, and use a you know, pond liner or something.
Yeah, pond liner. Yeah.
Yeah. Right. Because it's just for testing.
Yeah, it's just for testing.
Yeah.
Okay. Yeah, just a pond liner, and we tie it.
Yeah, tie it to, you know, create a you know, frame, right?
Yeah.
Yeah, and wrap, you know, from inside.
Yeah. And the table itself sit inside that container, you know, the bottom.
That's right.
And that way you get a liquid seal.
That's right.
Bubbles can't come out.
No.
Really.
Yeah, right. The whole thing is inside.
So, yeah, the sides extend under the water.
Yeah.
And so the bubbles are contained.
That's right.
Now, if we wanted to create a space in the middle of this tent, right?
Mm-hmm.
We could take a pail and turn it upside down, standing in the middle of the tent.
That's better, I think.
and you would have a little.
Oh, that I like that idea. You know.
Yeah.
Because then you don't have the connection. You got some air space, right?
Yeah.
You know, that's
It's kind of
That's a
like
good idea.
creating a void, right? You create a void
That's
inside
right. You create a void, and that's
by turning any kind of you know,
yeah,
like a barrel, a
yeah.
pail
That's
upside
right.
down.
Upside down, and then you hand the ice cube inside.
Well, you could do that too. Yeah, you could put the ice. You could put the ice inside that cavity,
That's right. Yeah, I like that idea because that
and then
then
yeah.
there's no interaction between the bubble and the ice.
Oh,
And
that's an idea. Sure,
right. Yeah. I mean the
sure.
ice, the air